Today I'm going to do a demonstration of electronic design automation lab, EDA lab for installation of your Tanner EDA. So my name is Dr. M. Rahim. I'm going to handle this lab. So what are the requirement for this lab is, so part C requirement, we had what are the software required. One is VMware because this Tanner EDA is going to work on Windows XP. I hope that every system is uh, installed with the latest Windows. So we need to have the old version of operating system, that is Windows XP, that Tanner EDA tool will work on it. So for that we need to have a VMware. First, you need to install the VMware latest one from your Google, and then you can, after installing VMware, you need to get Windows XP. Windows XP is software operating system which have been operated in student resources. So we had a create here. Then we do have idiot Tanner idiot. For this, so first I am going to show you uh, the VMware. So we do have VMware at here. So this is the virtual machine workstation. In this, we need to install our uh, XP. So for that already is there. So I'm just creating the virtual machine for operating system. So I just given a browse. So you can download whatever you had. You can download XP. So in downloads, I had Windows XP Professional. Now I'm going to install the Windows XP operating system. So for this, the key is provided to you. You just need to have take the key and then copy it here. So I'm going to copy my key. So then after copying this key, just keep next. So the space, whatever the requirement, that's enough for 5 GB or 10 GB, depends upon your project or design, what you're going to do it for Tanner EDA. So I'm just using 10 GB of my space for virtual machine. It's going to come in next. So first I copied my XP, which is admin password. I'm just not giving for password here. I have just making virtual machine name. You can change. So 40 GB is going to take default. I'm just using my 10 GB space. So you can make it virtual or split single file. So that's fine. You can customize it here, then finish. So now the operating system is for it has been created it here. So you can see it here. So it takes some time. It's nearly 30 minutes of time to install this Windows XP operating system. Once it has been installed, so it will be look after your installation, it will look like this. So I'm going to open which is already existing my XP, right? So I had one more virtual machine which I'm going to show you. So after installing, your operating system will be look like this. So after installing, you will find this type of older version of operating system. So then copy your Tanner EDA. So this is a Tanner uh, uh, which I have given in student resources. You had need to extract this. For the extractor, we need to have a RAR file because your freshly installed operating system, you don't have software. For that, in C, only one drive have been created. So we have been copied Tanner EDA here. Then you need to copy the RAR file. So then you need to extract. Once you extract this file, so you will find uh, extracted file here. So once you extracted it here, so these are the things you will find inside these things you had set up. So Tanner area, just you need to click next, next kind of stuff. So it's going to install. So taking time to install. So it will just installation is very easy process because only thing is you need to crack the license kind of. So you can, it's already there. So I'm just modifying. So let's install. So it is going to do it. So it will done, whole process will complete in just in 5 minutes, less than that. So Tanner EDA has been installed. So we do have, so I accepted all steps, anyone of on, okay, system. So final open, so local license, you just keep Okay, cancel. So you cannot start. So you had okay. Now it is installed on your at here. So if you find a warning error license issue here, so you had crack it here. So in this you will find crack. Just copy that crack folder, copy the crack folder, and go to the uh, Tanner EDA installation. So it is in the installation folder is at here. So just copy it here. In just a second. So it will be in program files, Tanner EDA. So you had need to copy this folder at here. Just I replacing again, copying first of all. Then just open this file and make this crack. Right. If you are uncracking this, so you cannot open your license at here. So once it has been crack has been done, so just open new design. Mm, you can create a folder. You can add the libraries. I'm just opening the libraries here. So open the okay. These are all libraries here. So I'm just opening one new design here, creating the folder here, mjct. Right. So I'm just making this new file. Okay, sorry. So it's not file. Cell new in all you had it. I just giving inverter design schematic. All right. Just keep okay. Okay, not a load. Okay, but here I had mjct folder, right? So I'm making inverter. Design name is mjct. I'm just creating folder. Cell name is inverter schematic. Okay, this is the folder where you just this is the window where you can play off it. Right. So you can add it here. All libraries. So this is my cell. So I'm just using it here. Miscellaneous devices and boss instance. Just take devices and boss. I'm going to use a free terminal. So just go for PMOS. So I have the PMOS and boss. This is your wire. Keep your wire. One click. Just make the changes. One click right. One click move and stop. Left click stop. Start and stop. One click start and stop. One click start and stop. One click start and stop. Alright, I had some input and output. So this is a R for input V, so I can make V in. This is the output port. I'm just using output port it here. V out. And I can go for this case here VDD, and I can also go for this go. So far so good. This is my design. You can save it. You can convert this into symbol, or you can also make this test bench to work. So I can use of uh, spice elements as voltage source, giving connecting it here, and I'm also going for voltage source as a pulse, connecting it here. So I had my miscellaneous ground, so I need instances at here ground, keeping ground, done. There's one wire connection is missing, so I can make this connection from here to here. I can also change, I just using spice elements for print voltage, what I need to print input and output. Alright, that's all. Just after my design, you can save this part. Then this is your T spice. The whatever you had make a design, it is going to convert into the spice netlist model, simulated program integrated circuit interface. For in this, I could add some files, library, source, channel EDA, so model. I'm going to add it here, keeping the typical case. So I need to make some print voltages. I can go for DC. Okay, to insert the command it here, and it is transfer time. I'm checking maximum time of 1000. Start with 0 nanosecond and 15 nanoseconds. Then I need to have, that's it. Then DC source, let's run for this.